Welcome everyone. In this video I will introduce time-of-flight mass spectroscopy. This method can be used by chemists to find out the proportion of different isotopes in a sample of atoms. The data can then be used to calculate relative atomic mass. This instrument also has other applications, particularly for organic chemistry, which we will look at later in the course. Let's get started. First of all, you need to be familiar with the following concepts. Atoms are the smallest particle of an element. Atoms are made up of subatomic particles, protons, neutrons, and electrons. Mass number is the total number of protons and neutrons in an atom. Atoms of the same element with different mass numbers, or different numbers of neutrons, are called isotopes. Two different isotopes of lithium are shown here. They both have 3 protons in the nucleus, shown as blue dots. Neutrons are shown in red. There are 4 key stages associated with time-of-flight mass spectroscopy: ionization, acceleration, ion drift, and detection. In the first stage, gaseous atoms must be converted into ions. Ions have charge, and it is this charge that will enable the ions to be accelerated and detected in later stages. There are 2 different ways that ions can be formed, and you need to be able to describe both with a chemical equation. Electron impact ionization involves an electron gun. Gaseous atoms are bombarded by high-energy electrons. This can knock off a further electron, forming a 1+ ion. The other method of ionization is electrospray ionization. A sample is dissolved in a solvent and injected through a hypodermic syringe. The needle is attached to the positive terminal of a high-voltage power supply. Atoms gain a proton as they leave the needle. In the next stage, acceleration, positive ions are accelerated using an electric field. Each ion has the same kinetic energy. The lighter ions travel with a greater velocity than the heavier ions. The third stage is ion drift. The ions travel down a flight tube towards a negatively charged detector plate. The flight tube is a vacuum. It only contains particles of the sample that is injected. The flight tube is a fixed length. All ions travel the same distance. Because the lighter ions travel with a greater velocity, they have a shorter time of flight. At the end of the flight tube, the ions impact a detector plate. The detector plate is negatively charged. Each ion accepts an electron at the detector plate and a current is produced. The size of the current produced is proportional to the abundance of each ion. The results could be shown in a graph. Alternatively, the results could also be shown in a table. M/Z is referred to as the mass-to-charge ratio. The mass is the mass of the ion and Z is the charge. Because each ion has a +1 charge, M/Z is equal to the mass number of the particular isotope that is detected. So that's an overview of the time-of-flight mass spectrometer. The 4 stages are ionization, acceleration, ion drift, and detection. There are more videos on the channel that cover calculations using the data produced by this type of instrument. Links are in the description. Thanks for watching. Please post in the comments if you have any questions or suggestions. Good luck with your studies and take care.